This recording is about the seasons. So here we're looking at Earth in early January, and we're going to look at it every week, so every 7 days. Notice that the northern hemisphere is tilted away from where we are, respectively. Where are we? We're on the sun, looking at Earth. So we have a telescope on the surface of the sun, so somewhere around 11,000 Fahrenheit, looking at the Earth, and the northern hemisphere is tilted away, the southern hemisphere is tilted towards us. So I'm going to run the animation, and I'd like you to pay attention to a couple of things. One is the tilt of the Earth, and the other one is the size of the Earth. It seems to make a little wobble as I'm going forward here in time, but Earth is always pointing towards the same part in the sky, which is, of course, is Polaris. But as we are on the sun, turning our telescope with the Earth orbiting, it looks like it's making a wobble to us, but it really is not. It's always pointing in the same direction, and now soon it's going to point towards us. Notice what happens to the size. Virtually nothing, right? Maybe actually it did become a little bit smaller, but insignificantly so that would matter for seasons. But now that North America is pointing at the sun, that probably means that we have summer there. And then we go, oh, there we actually have an eclipse on July 11th, 2010 in the southern Pacific and perhaps even South America. And then keep on going, and then the Earth is tilting away as we get into fall and now winter, November, December. And you might have noticed that maybe it did become a little bit larger as we went through December and January. So here we're looking at a day in winter where the Earth is tilted away from the sun. 7 in the morning, this would be Alaska time. The object that you see here is the moon. And here are the zodiac constellations. And I'm going to go ahead with 1 hour at a time. And then I soon will turn them off because now as we're getting to 9 a.m. where the sun hasn't risen yet. Now it rises 10 a.m. I just turn them on here so we can see Libra, Scorpios, and then here the sun is in Sagittarius, way below the equator, that is the celestial equator. And let me turn off the constellations. So again, you're an hour at a time. So 11, noon, 1, 2, 3 in the afternoon, 4 in the afternoon. And the sun has set before 5 p.m. So a very short day, a very low sun on a winter day. And as we saw, the sun rose in the southeast and set in the southwest. So here we have a summer day, July 3rd, and again 1 hour at a time. I start at 2 at night. Notice that the sky is relatively bright. Okay, the sun has risen. It's a little bit off the frame. As we can see, it's in Gemini, and again I'm going to turn the constellations off. So the sun rose in the northeast, and it stays in the sky for a long time. This is a little bit exaggerated. It doesn't make this huge parabola here across the sky because the sky is a dome, which is half a sphere, while here we're looking at it, and then it sets in the northwest a long time later. I counted in the neighborhood of 19 hours or so. Notice also that it was way above the celestial equator in the summer. So here where the Earth is tilted towards the sun, and it makes for a long day and for the sun to be high in the sky. So here we're looking at sun rays hitting the Earth with the northern hemisphere tilted away. And I'm going to put a slab of ground here on the Earth's surface in the south. And then I'm going to do the same thing in the north. And of course here I have to tilt it. And notice also when I do that, in order for the light rays to cover this, the entire slab, I actually had to increase its side. I had to make it longer, which means that the light rays that are hitting the Earth's surface less directly at a lower angle here are spreading out more. So therefore, since they're spreading out, they are less concentrated, and therefore it's going to be cooler. Here they're more concentrated as it's hitting it straight on, and therefore it's going to be warmer. And that, of course, combined with the time that the sun is in the sky during the day, gives us the seasons. In the southern hemisphere, in this case here, very long day. In the northern hemisphere, very short days. And 6 months later, it of course looks the opposite way. Notice that the Earth is tilting in the same direction in space, and we're on the other side of the sun, which means a moment ago we were to the left of the sun, now we're to the right of the sun. And again, I'm going to use the same kind of slab here, and then I'm going to take the same kind of slab again, and I of course have to move it a little bit here and make it longer so that the light rays are hitting the entire slab of Earth here. So here now in the northern hemisphere they're more concentrated, and in the southern hemisphere they're more spread out. So we have less heat, concentrated heat, reaching the ground. Here we have more, and again combined with longer days in the northern hemisphere. That's why we have summer, and shorter days in the southern hemisphere. That's why we have winter there.